All right, let's look at inertia and momentum, two very important concepts in physics. So first, let's look at inertia. This is Newton's first law. This is going to be based solely on mass, and the big idea about this, one thing you want to conceive here, is that the higher the mass, the more inertia it's going to have. All right, so defining this. First of all, know that there is not really a formula for this. You're not going to be asked to calculate inertia. You might be asked which object has more inertia, a low mass object or a high mass object. But inertia is the tendency of an object to resist a change in motion. I like to say a resistance to accelerate, because remember, acceleration is a change in velocity. So when you're thinking about this, think about F equals ma. And the reason I say that is because this is the only formula that we really use that involves mass. So think about, if we were going to throw some numbers out there. What if I had 20 newtons of force applied to a 1 kilogram object? Well, 20 times 1 is 20. So really, my acceleration would be 20. But what if I had 20 newtons of force applied to a 20 kilogram object? Well, 20 times 1 is 20, so here my acceleration would only be 1. So that kind of goes to show that it's going to require more force to accelerate a heavier object. All right. Now momentum is a little bit different. It also involves mass, but it's mass combined with velocity. Remember a couple of things here. First of all, your SI units. Your SI unit for mass is going to be kilograms. Your SI unit for velocity is always meters per second. This is something that's different from inertia though, because an object at rest does not, or that means not moving, an object that is not moving does not have momentum, while it still does have inertia. Alright, so moving and stationary objects both have inertia, but only moving objects have momentum. And the reason why is if you look at the v here, that's velocity. Well, think about it. If that velocity is 0, any number times 0 is 0. So here's an example. Let me kind of read it to you because I'm not sure if you can see it or not. Cody and his skateboard have a combined mass of 40 kilograms. So here's the thing. There's a kid on a skateboard, and if they're both moving together, you have to add those two masses together to get the total mass because it's moving at the same time. So the combined mass is 40 kilograms. He's traveling at a velocity of 1.1 meters per second by the time he reaches the bottom of the ramp. So you assume that he's on a ramp. To find his momentum, you take, so again, kind of looking back over here, remember the formula is P equals mv. The power of momentum is mass times velocity. So over here, I take 40 kilograms times 1.1 meters per second, and I get 44 kilograms by meters per second. So remember that the SI unit for momentum is going to be this, kilograms times meters per second. And that's because we don't have a unit for momentum. Just like density, we don't have a unit for density. We have to kind of borrow from mass and volume. Here, we're going to borrow from mass and velocity. So you write it just like this. Let's look at another example. What if we're trying to find the momentum of a car that has a mass of 1,000 kilograms and a velocity of 5 meters per second? Again, one thing I want you to be aware of is you might have to convert here. If I gave you grams, you would have to convert to kilograms. If I gave you centimeters per second or kilometers per hour, you would have to convert to meters per second. So everything needs to be in SI units before you do any mathematical operation. But just looking at how we would solve this, I always start by writing down the formula, and then I plug in the numbers into the formula. So my mass is 1,000 kilograms. My velocity is 5 meters per second. And again, that's going to equal P, which is momentum. All the other letters were taken. All right? So 5 times 1,000 is going to give us momentum is 5,000 kilograms times meters per second. And there you go. That's how you solve for momentum. Please complete your fever form, and we will review this tomorrow.